How that will respond. Ah, oh, that's very good. Yeah. What about Madhu and Ravi? Mm-hmm. Ah, from the very first batch. Yeah. Depends on the quality of the input that they've already. Let's put that some of the. Ah, yeah, right. Preparing more work. Is there anything planned after this or? We- Last week, here, she got some time off. My family was there. Yeah. No, we were trying to go, but it was so cool. It was the long weekend. Like wherever you go, occupied. Whichever will fall, so long. Now you can go. It's just like you're completely so long. A lot of people on the road. Whichever direction you go, so long. You talk about that thing, yeah. We can let people only read the article on 47, 48. Yeah, 47, 48. I have already told them online, but this one we can. Next week in full time. Uh, you, time class meeting, CTO is visiting from US. Yeah. Folks, are you back online? I don't hear anyone.
Yes,
Yes, sir.
Pavna? Okay, Pavna,
Yeah,
you're
that's-
saying you're back, right? Okay, great. So we'll wait for others to come in, but let's start reading quickly, folks, um, the articles that I've pointed out. Which are those articles? I'll just quickly bring them up on the screen. Yes, which is article number 47. We will begin with first, article number 47. And just glance through all of them very quickly, maybe in the next 20-30 minutes, and then we can start some of the discussion.
ಅಲ್ಲೇ ಅಲ್ಲೇ ಇಟ್ಕೊಂಡ್ಬಿಡ್ತಾರೆ ಇವಾಗ ಕಾಲೇಜ್ 8th ಸೆಮಿಸ್ಟರ್ ಆದ್ಮೇಲೆ ಸಿಗಲ್ಲ ಅದಕ್ಕೆ ನಮಗೆ
ಪ್ಲೇಸ್ಮೆಂಟ್ ಆಫೀಸರ್ ಸರಿ ಇಲ್ಲ ಇಟ್ಟಿರೋದು ಒಳಗ್ ಹೋಗದೆ ಬೇಡ್ರಿ ಅವ್ನ ಎಲ್ಲಿ ಪೈಪ್ ನೋಡಿದ್ರೆ ಸರಿ ತಲೆ ತೆಗೆದು ಕೆಲಸ ಮಾಡ್ತಿದ್ರಲ್ಲಿ ನೀವು ಹೋಗ್ತಿರ್ತೀರಾ ನಮ್ಗೆ ಆ ರಿಲೇಷನ್ನೇ ವರ್ಕಾಗಲ್ಲ ಅಲ್ವಾ
ಬಹಳ
Deep learning. Actually, we are the only noisiest class. I am the only noisiest person. बंद कर दो
save some energy.
डीप लर्निंग में डीप जाना है
डीप जाना है अरे यार वो ये
अमेजिंग थिएटर
पिक्चर
ओह ब्रेक मारे थैंक यू देवर
ಇದಕ್ಕೆ
पिक्चर ನೋಡಿದಿರಾ पिक्चर ನಾನು ಕಷ್ಟ ಕಾವು ಗೊತ್ತಿದ್ದವರೆಲ್ಲ ಮಾತಾಡ್ತಾರೆ ಓಕೆ ತಾಯಿ ಹೋಗ್ತೀನಿ ಕೆಲಸ
This was 7. Oh, yeah, wait. Sorry. There'll be the link. No, she's looking at the right one. I don't know how which one you're looking at.
machine learning connected.
Did it link to LinkedIn?
Even for him, it is going to LinkedIn.
No. The first thing is LinkedIn only.
Oh, now it is working.
Oh, okay. That's what I was wondering what is happening.
I don't know.
Yeah, anyway, so this was
Now it's fine.
Yeah,
Later it is going to his phone or his post.
yeah, that's correct. He already knows he can teach us.
Okay, yeah. Okay. You can
Whatever you know, you can bypass. No, just go through for it. Please tell me. Yeah.
And then take it from this table.
But yeah. Yeah. Chair is better. Shall we begin? Okay, anyone who would like to summarize what they've understood so far? Go ahead, Tejashri. Just unmute yourself.
Audible?
Yeah, we can hear you.
So I went through the very first article wherein it talks about what exactly is the difference between the different verticals, deep learning, machine learning, AI, and data science. So what I understand is that from across all of these verticals, the analytics and the data science part is like it has a transversal relationship where it cuts across all of the other three areas, meaning that whatever data that we receive, it is very important to drive insights and work with the data to be able to arrive at the output that the rest of them can that they have to offer to us. So that's more around that analytics and data science, which holds that transversal relationship. And when it comes to artificial intelligence, basically, this particular section is only trying to, help machines to develop a certain kind of an ability, which will be very close to that of the human behavior or an intelligence. And hence also the name has arrived that it tries to mimic and tries to give very reasonable and closer insights to that of what the human intelligence can gain and gauge and achieve at. And on the second vertical that we have is what is that? We have machine learning. So now from whatever we are having derived from artificial intelligence, so basically machine learning and the other aspect of it is they work as subgroups, or they are the derived groups. So machine learning will kind of become a subfield of AI, and similarly, deep learning will become a subfield of machine learning. So here in machine learning, this actually gives the ability for the machines or machine learning programs to learn from the behavior of the historic data, whatever data that has been fed into it, so that it can learn and pick up the behavior, and whatever it has gained insights, it will go ahead and use that training which which it would have seen historically, and try to help us to get some sort of actionable insights, or it'll help us to derive at a certain point, which can further be used for business value, or to bring some sort of an impact. And the last one that we have here is deep learning. So deep learning is again a subfield of machine learning, which further enables or enhances. Basically, this concept revolves around the way the human brain works. It follows the the biological thing, that like exactly how it works with all those neurons and dendrons, and we have a lot of other open-ended points from which it will learn, and then the multiple of such things will come together, and whatever is the possible best output. So basically, too many such stuff come into a network and try to give us some value. So that basically is a sum up around this. And we have different learning patterns, like we would have supervised learning patterns and unsupervised, wherein supervised is wherein we have a particular aspect which we keep as a reference, and with the help of the rest of the inputs we try to achieve what we have to do given the set of inputs. And unsupervised is the other case where the machine, the modeling, or this deep learning things would not be aware of what is that we are trying to achieve, but with the help of the behavior it tries to tell us what is the sort of the pattern, or how exactly is it, the kind of data that we see. It tries to help us to come to that point. So I think that's the sum up of this particular article.
Great. We covered a lot of grounds. Yeah. Anyone else would like to pitch in? What else that you highlighted? You can mute yourself, Tejashri. Anyone else online or any other place? Rabi, Vasu, anything from your side? Yeah,
For
go ahead.
me,
Yeah, go ahead.
yeah,
Go ahead, Zara.
actually, what I have understood of this article, that it starts from basically data analytics, data science, and uh, it goes to the machine learning, uh, right? Because this is how the data and the all process moves. First, it comes into data science. applying all data and their trends and everything into business context. That's a data science actually. So whatever patterns that we see in machine learning, the same that we apply in business context, that become data science actually. And yeah, artificial intelligence is like human intelligence, but it's like giving kind of self-learning capacity to the machines, right? So it predicts the actions or the output, right, based on the experiences, whatever
Yeah.
algorithm experiences accordingly, that artificial intelligence behave in the end. So
Thank you,
this
Zara.
will be,
Yeah.
yeah.
Awesome. Anyone else? Just unmute yourself so that others can hear online.
Yeah. So what the like whatever the contents are there, they are talking about this AI is the entire set. Like if we consider is a set, AI is one of the set where the deep learning, machine learning, all these are the subset or the branches of the AI. But like how like we are going to differentiate, like then why we are talking like AI and ML? Why not we are saying that this is only AI?
Yeah, that's a good question. Anyone who would like to answer why people use AI, ML, deep learning separately then?
So from
different
that time
different
onwards, I think it is keep on and taking their own words. Before 2012, I think deep learning was not there, but ML was quite.
Okay. Anyone else who would like to take a step?
In a nutshell,
uh, what I think in artificial intelligence is like a technology kind of
Because
technology.
robots are there from long time. It's not a new cancer. I think cancer. I think G healthcare. Uh, there are in US. I think maybe 2000 or those days. There are some cancer treatment.
When was the term deep learning used first time, or the phrase deep learning used first time in history?
Nineteen 1951, that time these were there. The after that in 2008 actually deep learning the first paper Jeffrey Hinton wrote in 2014 it kicked it off because of the that data set they proved that deep learning works better, right? ImageNet data set. So deep learning then started blowing up because it was not requiring any human features there. Like it was able to identify the features by itself. That was one revolution happened in deep learning in image. This one. Now they wanted to call this whole thing as something. So they put whole umbrella as artificial intelligence. Because still people are from that statistical background and machine learning, they still call it as AI and ML. ML applications are basically more of a tabular data kind of thing where numbers are there and you want to predict something like weather forecasting something. Artificial intelligence is human intelligence where we can immediately see and make a sense of it, like banana, apple, something. That is where this deep learning evolved too much. That's what my perspective.
I think yeah, that's true. So when it comes to like autonomous car, maybe uh, the Tesla, they whatever they are building, right? So uh, I think they must be using image processing to find out any obstacle is there, then take the action.
real-time processing.
And I think in Hyundai, recently they are some showing some ad there. I don't know how that
Real-time
is.
processing.
Huh?
Real-time processing. Real-time image
I
processing.
doubt.
No, object detection has to be in real time. If you're
Yeah.
making a self-driving car, no use after 10 minutes.
Right. And there should be speed limit also, right? So if
Right.
somebody is going 200 speed, will you able to detect? That is
Yeah.
also.
So no, I mean, I think that's a great question. I mean, artificial intelligence is like, any sort of, intelligence that we human have. How many years of training that our brain has gone through? Billions of years, right? Because we get this information passed on from our parents, from their parents, and so on and so forth. We've been trained for billions of years, actually. Machines have not been trained. So that's where we're actually inducing that intelligence in them. Machine is not born with a brain. We actually put the CPU and GPUs and memory and all those things, instructions for them to do, right? So that's what the artificial intelligence is. They're not intelligent. No machine is intelligent. We are artificially inducing the intelligence in the machine. That's the term artificial intelligence, right? But people use robot and whatnot to really capture that. But even system is AI. This system is AI, artificial intelligence. Calculator is also AI. I mean, because we have fed the instructions. When somebody presses this button, that means 2. When somebody says this cross, that means multiply. Multiplication means this. So it's basically a set of rules that we've actually given it to that, right? To create that intelligence. Machine learning is what we do. Like, I mean, linear, logistic, all the models that we have. Deep learning is a subsection of machine learning. And the thing which is unique about the deep learning is that it's a particular type of model that we're looking at.
Article says where we don't have labels.
No, that is not true. In fact, it
layers.
works with, yeah, it works with
Yeah,
labels,
yeah.
right?
In
Yeah,
the layers, hidden layers kind.
yeah, absolutely. So, this is both your supervised plus unsupervised models, right? Some examples, linear regression, logistic regression, even your Excel is a machine learning for that matter, right? All the models are there. This is a special type of model which is called as a neural network. Neural network, right? And we'll talk about that. And this basically mimics the human brain performance. So ultimately, our brain's components are neurons, and they fired, and they actually tell you a certain things to do. So, for example, when a small, let's imagine few months old infant, right, does not know how to communicate and all that, and the infant touches a hot surface, immediately the body will pull it back. That's the neurons. Like how that reaction happens, we don't know. But that is fed in the system in terms of just how it should work. That's the neuron, right? Deep learning is exactly that, that how the model works, we don't know. But neurons train to really create a certain output. That's the most fundamental difference between the machine learning and deep learning. Machine learning, you could tell that if I change the parameter room by X%, this is how the price of the house gonna change. In deep learning, you cannot do that. If I change by X%, that is Y% is going to change. You can get a relative feature importance that which variable came out important. And I'll talk about when we look at the TensorFlow in a minute, the playground. But that's what the deep learning is, a completely black box model. And why is it called deep? Because what may happen is that you may have, so each of the neural network will have 2 layers. So your input layer and your output layer. And then it will have 1 layer in between as well. When these layers increase by a higher number, let's say more than 5+ layers, it's called a deep neural network. Why? Because there are too many things in between over here. And what happens in this is a mystery or black box, right? Like in the depth of the sea, you don't know what really happens. So it's basically that sort of thing that happens in the neural network. But of course, I mean, we know a lot to really train them on. So that's how they really work, right? And of course, I mean, there are some other nuances that you have called out, but there are tons of applications. So voice recognition, for example, or the speech recognition, like in Alexa, right? So there have been, millions of data points which have been fed in terms of the voice recording, and then we feed the transcript. So we say when I am talking like this, that's what it means. So voice recording, transcript, that's how basically Alexa gets the conversational thing, or Siri gets the conversational thing that we're looking at. Stock market data, that's what you create the bots. And a lot of times these bots do crazy things. Have anybody heard something about the bots in the stock market? What is it? Algo trading, yeah. So what are the stories you have heard? Yeah. Right. Right, right.
Yesterday at 3:50.
So is it? Okay. It suddenly dropped. Okay, okay. So those are the robots basically. Those are the bots doing the trading, right? So what are the bots doing? They are saying if the market reaches this level, that's the support level, right? That means the market is going to go higher, or if it reaches this level, it's a resistance level. The market is going to come down. So the instructions are already fed. That if you see this and it's moving, 200 moving days averages and higher and all of that, and many rules, right? There are like some charts that people call them. I mean, all sort of crazy stuff. Head and shoulder pattern trade, and they will trade in a certain way. When all the bots get together, the market will do suddenly something which humans cannot really tell what exactly happened there, right? So that's what basically sometimes the bots can go haywire. So when the market crashes, you'll see that it crashes like anything. Like when it goes down, it will go down like 3,000 points, 4,000 points. Like I mean, ridiculous level because of these bots until human intervenes and then they try to stop some of this bloodbath, right? Or it can go higher also for the same way. So there are many applications. I mean, but everything has been trained. Most of the models that we have, like almost 90% of the models that we have as of now are supervised. And this is true for both ML and DL. In fact, DL will actually ask for a lot of more information compared to an ML model, right? So that's where this graphics from enduring comes in handy, that if you have small data, no point for you to build a deep learning model. Don't overcomplicate that. But if you have large amount of data, right, which ML models will suddenly plateau, they will not actually be able to do more learning. That's where the deep learning models really come in. And it's just not about the amount of data, it's about the type of data as well. So deep learning loves unstructured data. So this is mainly cut out for deep learning. Structured data, like Manju was talking about, or somebody was mentioning, I think, is more for tabular data, right? When you have like rows and columns and all those things. What is an unstructured data? Who can give some examples? Your images are unstructured data. Your text are unstructured data. Voice is unstructured data. Videos are unstructured data. What else? Geolocations, right? I mean, it may vary very quickly. Like, I mean, the real world data is unstructured. The real world data does not come in Excel, right? So the real world data is all unstructured. So that's where, I mean, you can see that any type of self-driving or robot or any sort of automation that you're looking at, which is working in real world, will be most likely working on the deep learning and not the ML model. It's as simple as that, right? So that's where it really comes in. And deep learning is more experimental, right? So by very nature, deep learning is more trial and error or experimental. And there's one type of learning which is called the reinforced learning, which is like in between the supervised, deep, and all of those. That is 100% trial and error learning. Like how you would train your pet to do certain things and create the reward mechanism and all of that, right? So we'll talk about that. I'm just gonna be moving on in interest of time. You already know these descriptive diagnostics, so unless there's a question, I'm gonna skip that. This I'm gonna skip it as well. I don't know what exactly is here. Anything worthwhile? Might be already Okay, so O'Reilly's, I'm gonna skip that. Introduction to neural network and deep learning. So this is what I will walk you through, but I was able to dig out another good presentation from my from my first employer. Let's see if I can share that with you. Texas Instruments. I didn't know that they are also doing deep learning. It was a big surprise for me. See, TI, Texas Instruments. They have no business doing deep learning, but they are. So, but they are doing the chips which actually do the recognition, right? So that's where they're coming in. Very cool graphics, actually. I thought that they have done a phenomenal job in laying it out. So I'm just going to share that. But not all the slides are relevant for you. So I'll just share this presentation afterwards. But I'll draw your attention on some of them over here. So artificial intelligence, broad area which enables computers to mimic human behavior. Machine learning, usage of statistical tools which enables machine to learn from experiences. Experiences means nothing but your data, old data. And you need to be trained on this, right? Deep learning, learn from its own method of computing, its own brain, right? So that's why it's called the deep learning. And this is an example of a deep learning. So can anyone look at this picture and tell me what exactly it is doing? What will be the broad area of deep learning over here? Object detection. So it's telling this is a car, this is a human, this is the road, this is a tree, this is a signal, all of those things, right? Now they have captures, they ask you to say all the traffic lights, so you can build a deep learning engine to say traffic light, and then you can bypass that capture. But I mean, right now it's not that accurate, right? So it's basically, that's what we're looking at. So basically this is a chip that TI has built, automotive driver assistance system, ADAS system that TI has built, right? Where they are actually deploying that. So they are saying you don't need to train that. As long as you buy that chip from me, that chip will come in with this inbuilt functionality where it will be doing this object detection for you, right? Is it? Right. So I was not familiar because I was working more on DLP. This chip, ADAS, automatic driver assistance system. Hmm. Got it. Yeah, so this is an inbuilt chip, which is actually not just having the hardware, but also having the deep learning system sitting on that and working on it, right? So this is what the deep learning is, right? So machine data, variety of different data is able to tell you what exactly you're looking at. Basically, the main purpose is classify, cluster, or predict. There's no difference. Just like in ML, deep learning is also trying to do the same thing, but just like the data is very complex for the ML algorithms, right? And this is how it works, right? So some parallels with respect to human intelligence and how exactly it works. So I'll give you a second to take a look at this. This is a biological neuron. I mean, I don't know. I mean, I'm not a biologist to understand what exactly this thing means really, but this is how apparently a neuron looks like in our brain, right? And then that neuron is artificially created into a neuron that you see down below, right? So, and they have done a phenomenal job in comparing the like different aspects of the neuron. So dendrites are the inputs. Dendrites are the ones basically which are your senses, right? I mean, what exactly is happening. So they are actually sensing, getting the signals, right? So those are your inputs. Synapses is basically the weights, which signal to respond to, which signal ignore. Like if you really have a very like talkative coworker, so your brain has been trained to ignore that person over a period of time, right? Half the time he's saying junk things, right? Versus somebody who rarely speaks, your brain is straight over, let me just hear what this person is saying. That's exactly what the weights do. They say, I'm just going to ignore this signal. Nothing important for me, right? Versus, something that I should react to. Axon is your output, basically that comes in from the other side of the thing, and then cell body is where all the math happens in terms of the summation and threshold, right? And basically, when the artificial neural network trains on, it will randomly start with the weights, and over a period of time, it will figure out what are the right weights to get the correct thing done, right? And I'll talk about that as we go on. So this is how a neural network will look like. You have an input layer, you have output layer, you have in between neurons, and there are many neurons that you can control how you want to do it, right? So this is how an image recognition will work. So you're feeding an image, and this image engine or convolution neural network has been trained to classify the animal into three different types. It will say whether this is a wolf, a dog, or I believe this is the third one is a horse or something, right? So it will be trained on that. And basically the convolutional neural network will look into the images and look into the different size pixels to figure out what exactly is happening. It uses filters, it uses convolution layer, it uses some other techniques to really figure out whether this is a dog or something else, right? So it says I'm 90% confident that this is a dog, which is basically spitting out the probability as we have done earlier on. This is what we will cover today, multi-layer perceptron, but everything works sort of the same way, right? So convolution neural network works for images and voice and things of that nature. MLP works mostly for wherever the ML will work very good. That's where MLP can be deployed. Recurrent neural network are the networks which have the memory, right? So they work very well in terms of the text. So for example, if I just build an n-gram, which I don't think you've done the text, right? So, but I say the food is good, right? Not bad. Or I say the food is bad, not good. They are two different things. But if you do the n-gram, they will say exactly the same sentiment will come out. That there is one time good, there is one time bad, but they just misses the context of what is happening. That's where your RNN will really come in. They will say the good came out first and then came the bad. So I'm storing that part in my memory. I know how this person is trying to say that, right? And then similarly this. And a lot of people use this to detect the sarcasm and things of that nature, right? And so on and so forth. And all the airline companies also have bots to respond to the Twitter, right? So if somebody says, Indigo, thank you one more time for delaying the flight. So I missed my meeting, and says, you're welcome, right? So all those things happen. So it's because of the bot, and they miss the point of detecting the sarcasm and all of those things. So text is very hard. Text is very hard, much harder than anything that we know, right? So all those things. So that's where these RNNs really come in, and a variation of that is LSTM and so on and so forth. So I'm not going to go in many more details, but these are different types of frameworks that we can use, and we're going to use what we call as TensorFlow and Keras. TensorFlow is what basically makes a deep learning algorithm trained, but nobody, I mean, none of us, we will be in a position to train a TensorFlow, and we shouldn't be, because it's like, somebody wants to drive a car, you say, you go build your own car first, and then come and drive, right? Why would I do that? So TensorFlow is like, sort of like, building nuts and bolts and everything, and then coming out and then doing that. So nobody needs to do that. We're going to leverage that package. And Keras is making you even more lazy by having a layer on top of that. So Keras works with Theano, Keras works with TensorFlow and some of the other packages over here as well. PyTorch is very important one. And Gluon is, you heard the term earlier, auto gluon. Gluon is basically not the auto part, but the gluon part, right? So that is there. Okay, so then with this, I will switch to my slides then, because that gives you more fundamentals of what we're doing. And then we will go and do the hands-on exercise, right? I will do that, yeah. How do I, there you go, okay. So we already spoke about that. Nothing new. This is all there. Yeah, so these are some of the challenges. It works better with the large amount of data. May not be easy to train the models. Some models may take weeks or months to be trained. They're not necessarily like plug and play, right? So it can be really, they may suffer from overfitting because we don't know what exactly they are doing. Black box, and hence cannot be used where you need to have regulatory challenges and all of those things. That's where your point, Rabi, was coming in, that when you have the consumer facing, it's easy, right? When you need to show what exactly your model is doing, it's harder, right? And it's not easy. So for example, over here, what is chicken, what is puppy? I mean, even a 3-year-old kid can identify very easily, right? But the deep learning model says, go give me millions of these images. You know why? Because each image is different. Same chicken I can hold in multiple poses, top, down, this, right? And every time the machine learning algorithms will get confused. But our human brain can process that very quickly, that this is chicken, this is puppy, right? So all of those things are there. Not easy. These are the building blocks, and we will use the perceptron, which is the most fundamental as a deep learning model, and that's what we're going to try, right? They are the feed forward networks. What does the feed forward mean? So for example, you're providing the input. So input could be your Boston housing data sets, like the number of rooms, the lower strata population, so on and so forth. Your output is what is the house price that you're looking at, right? Or when you're doing the Titanic, whether somebody was female, what age group, what fare, and all of that, and whether they survived or not survived. That's your output. And these weights can be initialized or they can be randomly set, right? So there are many ways people can initialize these weights. And each of these circle is nothing but a neuron. And they either fire or don't fire, right? Fire meaning they will either activate or not activate, depending on the signal that they are getting. And then they will turn off for a period of time. And these are the dense layers. Why is it called the dense layer? Because each neuron in the current layer talks to the neuron in the previous layer. So for example, 3 is connected to 1, 3 is connected to 2, 3 is connected to all these n neurons that we have. They're all interconnected. These are dense layers, right? So they're all passing on the messages to each other. So what happens is randomly it will initialize the weight. It's let me just try to see what house price I predict. So let the weight of this be 0.3, 0.21, 0.1, whatever, right? And then I will calculate the house price over here. So then I know the house price is off by the actual amount by X. And that error is backward propagated. When I looked at your signal, you were the one who gave me the wrong information. It will tell to those neurons. So you better keep your mouth shut. So that neuron will be turned off. You're giving me the wrong signal. You're not needed. Second neuron, you're doing a good job. Keep on giving me the signal. So that signal will become stronger and stronger. Basically, that means the weight will get more focus on it and so on and so forth. And that's how basically over a period of time, the network gets trained. So a live demo is right over here, which will give you a picture of that. I mean, that is something that you can keep on playing day long and you will still be mesmerized what exactly it does, right? Somewhere I have opened that. So this is the TensorFlow. So this is your feature engineering, Ravi, that you're talking about. So I have x1, x2. If I create x square, that's a new feature. If I create x2 square, that's a new feature. x1, x2, another new feature. Sine of x1, sine of x2. So this is what my inputs are, right? And I'm just having one layer, 4 neurons that I'm passing on. And these are the neurons which are actually the output layers that we're looking at. And you can see these are the weights which are initialized randomly as of now, right? If I say, I mean, there are many different things that I will talk about that later on, but let's say I say, go ahead and train that, and I want to train this image. So do you think any linear model can be built which can detect the blue from the red? Very hard for any linear model, any decision tree, anything of that nature to really say, okay, how can I separate the blue from the red or the orange? Is it? Okay, awesome. So you can have like many different images and all. This is easier. Uh, Even this is easier, but this is super hard. Let's see what happens. Right, so you can see the weights have immediately started to change. And these thicker lines mean that more weight is coming in from that, right? Over a period of time, you'll see some of these neurons will stop completely, or they will just send very weak signal. So now you can see the weights are getting stronger and stronger. The decision boundaries are getting better over a period of time. So the orange is basically one decision boundary, the blue is the other one. So it's just trying to separate that. Okay, so this will keep on going, right? I mean, this is like, this will take, but you can see this wasn't this thick actually when we started, much thicker now, right? And some of the neurons are actually losing their power. Like, I mean, this is feeding that, but there's hardly any signal going to that one, right? Somehow these two neurons seem to be providing the separation of the orange color. So these are processing the orange. These neurons, this neuron itself is processing a lot of blue, right? So blue is basically nothing but the classes. So it says, okay, I can identify a dog for you. I can identify a cat for you. So this signal, blue signal is getting processed heavily by this neuron. The orange signals are being processed by the middle two neurons. And this is actually not doing a lot of things. You can actually add on the layer. I mean, on the fly, you can do more things. And I can, features are limited. I think that's all they're saying. But let's see if I can add more. You can see now it's going to train differently. Because of the more neurons, you can see it's actually able to zoom in faster because it's adding more power in the neurons and able to find out what exactly is happening. Very good overall performance right now. So the blue line is already defined for you, right? So good performance so far, right? So what exactly these things are, we will talk that in the deck that I was showcasing. Only the fundamentals I'm covering. This itself is like, several days learning that we should go through, but we don't have time for it. Right. So they will have an input layer, output layer, and many interconnected hidden layers and neurons that will be forming that, right? They will use some sort of non-linear activation function such as ReLU or 10H or sigmoid and stuff like that to compute the losses. What is a loss? the actual value versus the predicted value. That's the loss, right? And they will try to minimize the loss. And this loss is backward propagated to adjust the weight and train the network. And activation function basically initializes this, and it's nothing but your neuron times weight and then some bias that we're looking at, right? What are the key components? Number of layers, input layers, output layers, hidden layers. More the number of layers, the deeper the network. Number of neurons, these are the things that you have to optimize. How many neurons you want to have in each layer, right? So input layer neurons will be exactly the same as the number of features that you have. Output layer neurons will be the number of outputs that you want to generate. And hidden layers neurons, you need to be optimizing for it. Weights can be initialized randomly. They can be initialized in a uniform distribution. They can be initialized in a normal distribution, so on and so forth. Activation functions, as you've spoken about, there are many. We'll be looking at that. Forward propagation is the initial set of weights are used to make a prediction and sent forward to compute the error. Errors are backward sent to the network to optimize the network's weight, right? And loss function is basically nothing but the difference between the actual and the predicted values. It could be mean square error, it could be log loss, it could be cross entropy, it could be anything. And these are some of the activation functions that we look at. TANH looks like this. Most of the times we'll be looking at the ReLU. So what does the ReLU do? Can anyone tell me in plain English?
So it's combined weight plus bias. Go beyond the threshold. Okay, I will give the value, whatever that comes out. If this comes below the threshold, I'll give it a 0.
Right. Yeah, exactly right. So if the signal is less than 0, it won't send on.
Yeah.
If the signal is more than more than 0, then it will send on the signal. Right. So that's what basically. Then there is a logistic regression type model sigmoid. Then there's a leaky ReLU and all of that. Backward propagation means for the error. And how do we really optimize the weights? Because I can be sitting and doing this all day long, right? But there are optimization algorithms like stochastic gradient descent and other algorithms like ADAM and all of that we'll be looking at that we can use to optimize the weights in a faster fashion. Epochs, one complete set of feed forward and back propagation is one epoch. So when we were looking at this, sorry, I think it's in the same one. When we were looking at this image right over here, the TensorFlow network, it says I have done 604 epochs, right? So 604 times the signal was sent forward and error was sent backward. Signal was sent forward, error was sent backward. 604 times it has already done that. That's an epoch, right? So that's what we're looking at when we are looking at the training of the model. Right, so let's continue. Batch size, number of input observations which are processed in one epoch. So it's not necessary that you grab all your data and send and then take it back, because what will happen is the learning will be too fast and it may not be optimized. So it's okay. First 8 rows I will grab in this epoch and send it forward and error computed backward. Next 8 observations I will send this, or randomly we can send that, right? So that's what we have. Dropout. What is dropout and what is the concept of that? It will randomly say some of the neurons you switch off, that you do not send any signals. Why? To regularize the network. Huh? To avoid the overfitting, right? So randomly it will say some of the neurons you switch off in the next iteration, and that will basically make sure that the signals are valid signals, that all the neurons are saying the same thing, not that like when one guy is off and then he's actually deciding network, right? And optimizers and learning rate and all of that, those are some of the things that you've spoken about. Learning rate, if you do too fast, like if you try to learn data science in 5 days, how will be your learning? Versus if you do gradually for 5 months or 5 years, right? So it takes slow amount of learning for longer period of time to get a better result. But do you have that much time to train a network? So that's why you have to optimize. I want to have an optimal learning rate. These are different models. I'm not going to go into the architecture. This is an unsupervised algorithm. This is for the image and some of the other data. Convolution neural network, what are the parts to it? Recurrent neural network, we have spoken about that. and some of the other things, right? So what we're going to do now is we will get into installing some of the things. And remember, if you're in the Colab, you don't need to install anything. But if you're in the Jupyter notebook, then you have to do it. So which one you're going to use now? Colab or Jupyter? Colab? So let's follow this example over here, folks. You will have this working example. Oh, sorry. Before I go to the Colab, very important point. What we haven't spoken about, Keras. What is Keras? Which is over here. So I'll give you some time to go, or have you already gone through this one, Keras? So let's take maybe another 10 minutes to go through Keras, because this is what we're going to use to build a neural network. 10 minutes will take. Or are you going to break for the tea? Tea? Huh? Tea, I think should be there, no? 4? Okay, so she will let us know when the time is right. 4 will be late, they are saying, huh?
Yeah.
Okay. 10 minutes you can read and then we can come back.
Hello, sir.
Yeah.
Sir, can you share the PPT, sir?
The one that I spoken about.
Yeah, sir.
It's there in this link actually. The one that I was talking about, the TI one I'm gonna send right now.
Okay, sir.
This is the right link.
Sir,
Now
could
you
you
have
even
it.
share?
Hmm?
Sir, could you even share that Excel sheet, sir, that you have explained now, sir?
Acha. That I will save and then share with you. Yeah.
Yeah, sir. Okay, sir. Sure.
Okay.
And today's codes also, sir.
Codes are there already. Codes I've
There.
already sent. All
Okay.
of the codes I've already sent.
Okay. Thank you, sir.
Yep. So we go for it. Not the thing. This was morning coffee. I hope they repeat it because I'm going to have it now. Folks, we are taking a quick 15 minutes break for tea and we'll be back at 4.
More like a same tagline of this. Company.
Thanks. You must be
Bye.